Hello everyone, welcome back to Precalculus. Today we're in Chapter 2, Section 8, talking about composition of functions. Okay, so the first composition we're going to be talking about is the sum and difference of two functions. So if you have two functions, f and g, added together, that's the same as taking your f function and just adding it to your g function. Essentially, we're going to be adding like terms. Okay, the domain of that function, of that composition, is going to be the intersection of the domain of f and the domain of g. So if p is the domain of f and q is the domain of g, the intersection of the composition is, or the domain of the composition is going to be the intersection of those two domains. And the same thing holds true for the difference of two functions. Okay, is the same as taking the difference of the two functions, subtracting like terms. Your domain is still going to be the intersection of the two individual domains. Okay, the same thing holds true for multiplication. So the multiplication of two functions is the same as taking function f and multiplying it by function g, often using the distributive property. Okay, the domain there is still going to be the intersection of the two separate domains. We'll talk more about what that intersection looks like here in a moment, but you're probably picking up on a trend. Lastly, the division of two functions is the same as taking function f and dividing it by function g. And the domain of the composition of functions is going to be the intersection of the two domains, but you also have to recognize that we can never divide by 0. So g of x can never be 0. So we can never have whatever makes g of x 0. Okay, so let's dive right in and take a look at these two functions. Okay, this function f and this function g, and we're being asked to subtract it. Okay, so h is equal to the composition f minus g. All right, we're going to worry about the domain here in a second. Okay, but what we're going to do is we're going to figure out what is h. Technically, what is h? Well, h is equal to f minus g. So that's going to be f, which is 2x plus 1, minus g, which is x squared plus 2x minus 1. And now we just got to do some combining of like terms and everything and distribute our negative sign here, and we should get, so we have a negative x squared. Okay, we have a 2x here minus a 2x, so those are going to be gone. We have 1 minus negative 1, so that's plus 1, so that'll be plus 2. Okay, so there is our new function h of x. That's what happens when you take f minus g. You get negative x squared plus 2. Okay, so let's go ahead and evaluate what h of 3 is using the definition. So h of 3 using the definition is f of 3 minus g of 3. Okay, so just plug 3 into f. 2 times 3 is 6, plus 1 is 7. Plug 3 into g. You get 9 plus 6 is 15. Minus 1 is 14, so 7 minus 14 is negative 7. Now we're being asked to use the new rule for h. You use this. So let's evaluate h of 3 using our new function, negative 3 squared plus 2. And you're going to see something really cool here. You're going to see that 3 squared is 9, negative, so that's negative 9 plus 2 is negative 7 as well. So you should be getting the same exact answer here. No matter if you use the original definition or the new definition of h, you're going to get the same number. Okay, so lastly, let's go back and revisit here the domain of each one. So let's draw a number line for f, and let's draw a number line for g. Okay, now let's look at each function individually. So function f, 2x plus 1. There's no even radicals. There's no division of a variable. So we know our domain is going to be negative infinity to infinity. Looking at g, again, we see no even radicals, no division by variables. So we know our domain is going to be negative infinity to infinity. So now the intersection, f plus g, as up here, the intersection of those two domains, wherever they overlap, whatever values they share, they happen to share in both number lines. We have values from negative infinity to infinity, so our domain of h is going to be negative infinity to infinity. Okay, now you're going to take a moment to pause your video, and I want you to do the next two examples on your own. Okay, this one you're going to be multiplying f times g, so h will end up being 3x times radical x minus 5. Okay, you should know how to figure out what the domain of radical x minus 5 is from previous sections. Okay, so you'll be looking for a slightly altered domain of h because this has a restricted domain. And same thing down here. So you're going to be looking at two functions that have domains of negative infinity to infinity, but since you're dividing them, remember that you have to figure out what numbers make g equal to 0, and you can't have that in your domain as well. Okay, so take a second, pause your video, and get example 2 and example 3 done. Okay, now let's talk about the composition of functions. So in a function g, the x acts as a placeholder for our input. Okay, you can think of the function as a giant machine. For g is equal to, let's call it x squared minus 3. Our input is squared and 3 is subtracted from it. Okay, so if we're looking at g of negative 5, that means you take negative 5, square it, and then subtract 3, and you end up with 22. Okay, if g was or if x was 5t, you would take 5t, square it, and subtract 3. You'd end up with 25t squared minus 3. And lastly, if x was t minus 4, you would end up with t minus 4 squared, and then you'd subtract 3. You can probably FOIL in your head and know that you're going to get t squared minus 8t plus 16 minus 3, so this is going to be plus 13. Okay, so just a matter of taking whatever you have inside and plugging it in for x, wherever you see x. Okay, so when the input value is itself a function, this process is called the composition of functions. When you're plugging a function into another function. Okay, the composition of f with g is defined by, you've probably seen this before, f with an open circle, g of x, or sometimes you see it written as f of g of x, which is most commonly how we're going to refer to it. Okay, so you can see a little visual representation of what that means. So when you have a composition of functions, you take x, you plug it into g first, you get something out, and then you plug that value into f, and then you get something out. Okay, so when you're reading this, you're taking your x value and plugging it into g first, and then f. You're working your way inside out, essentially. Okay, so let's take a look down here at some examples. Okay, so we're being asked to find f of g of x. Okay, remember that's f of g of x. You're taking g and plugging it into f, and there's our g and f functions. Okay, so we're taking g, this whole thing, and plugging it into f wherever we see a x. So that's going to be negative 5 times, we have an x there, so we're going to plug all of g in there. Square root of x plus 3, and then we have another plus 3 on the end from this plus 3 over here. Okay, g of f of x, written as g of f of x, looks a little bit different. Okay, now we're taking f and plugging it into g. So we're taking the square root. Now we have an x, so we need to plug in this whole thing. So negative 5x plus 3, plus we have another 3 already in there, so that's going to end up being negative 5x plus 6. Okay, so now we're being asked to find the domain of the two compositions. So first things first, we're going to do the domain of our first function here, negative 5 times radical x plus 3 plus 3. Okay, so When you're doing composition of functions, you really only care about the domain of your input. Okay, so what's the domain of G? Looking at this. So the domain of G, you should be getting really good at this stuff by now. Anything underneath a radical has to be greater than or equal to 0. So x plus 3 has to be greater than or equal to 0. So x has to be greater than or equal to negative 3. That's a 3. Okay, x has to be greater than or equal to negative 3 in G. And then you care to look at the final function. So does the final function domain change at all? Well, we end up with the same thing. We end up with an even radical with underneath the radical says x plus 3. So it's going to be the same as this. So your domain is going to be negative 3 to infinity. Again, I can't say this enough. It's important to understand we only care about what's the domain of our input and then the domain of our final. Okay, so let's take a look over here at our other example. So what's the domain of f? The domain of f is negative infinity to infinity. So the domain of f is going to be negative infinity to infinity. But it's important now we have to look at this. We have to say, okay, well, I'm allowed to put whatever I want into f. That's great. But now look at your final function. Can I put whatever I want into this final function now? No, it's underneath an even radical. So I know negative 5x plus 6 has to be greater than or equal to 0. Subtract your 6 and divide by negative 5. That means x has to be less than or equal to 6/5. So our domain is going to be negative infinity to 6/5 inclusive. Okay, so remember, look at your domain of your input first, your inside function, and then look at the domain of the end result, the final composition. Okay, now I'm going to ask you to pause your video and do example 6 the same way. So we're taking f of g, you're going to be taking this 3 over x and plugging it in everywhere you see an x into f, and you're going to find its domain. So remember, you care about the domain of g, and then you care about the domain of the end result. So a little bit more difficult of a problem, but I can definitely help you in class once you've tried this on your own. So pause your video and try it on your own. Okay, so now we're back. And we're going to be using this picture below, so I'm going to be doing some sliding around here a little bit. But we're being asked to use the graph. Now we don't have equations, we just have graphs. Obviously, there's no equation to map this. It's a bunch of piecewise functions added together. So anyways, we're being asked to find f plus g of negative 3. So what that creates is f of negative 3 plus g of negative 3. Remember, negative 3 is just our input. So let's figure out what f of negative 3 is first by looking at our graph. So here's function f. And when you input negative 3 into function f, you get out negative 4. So f of negative 3 is negative 4. The y value is negative 4. Same process with g of negative 3. So g of negative 3, let's slide down here and look at the picture again. When you plug negative 3 into g, you get out 1. So f of negative 3 plus g of negative 3 is just negative 4 plus 1, which is negative 3. Okay, now let's do f of g of 2. So f of g of 2. So remember, we're working our way inside out. Actually, you know what I'm going to do is I'm going to change this 2 to 1, folks. We're going to make things a little easier on ourselves so we can see it. Let's change this 2 to 1. Let's just alter the example so we can see it a little bit better. Okay, so g of 1. The process is still the same. G of 1. Let's go down here and look at our picture. What happens when you plug 1 into g? You get out 1. So g of 1 is the same as 1. So now we're just being asked to evaluate what is f of 1. Let's go down here. F of 1 is negative 2. So our answer is negative 2. Okay, right now I think you should be more than able to evaluate g minus f of 5 by doing g of 5 minus f of 5. I want you to pause your video and see if you can get that answer on your own really quick. Okay, you should have gotten that answer. I'm not going to write it up. You can ask in class if you want to know if you got it right or not. But now let's do our last example. So we're being asked to graph f plus g of x. Here we have an f of x, this wacky line. We have a g of x, this is a wacky line. Now we're being asked what happens when we graph them added together. Added together. So all we have to do is we have all the same inputs for these graphs. So all we have to do is add together the outputs, exactly like we did up here. It's no different. It's this process a bunch of times over and over again. Okay, so let's take a look down here at our picture. Here g is 1 and f is -5. -5 plus 1 is -4. Remember, we're being asked to add them together. That's why I'm just taking the outputs and adding them together. -1 plus -3 is -4. Zero plus -4 is -4. There you go. Notice I'm just lining up the dots that I have. Okay, I mean the values that are in between should follow suit. Okay, since they're just a bunch of straight lines. 1 plus -4 is -3. 1 plus -2 is -1. 7 plus -2 is 5. And 3 plus -1 is 2. Let me just go through and double check this real quick. Everything looks good. I'm going to go ahead and draw my line. Connect the dots. And this red line here is f plus g of x. I look forward to helping you guys in class and wrapping up chapter 2.